Hey there, Angela. Are you able to hear me?
Hey there, this is Joe. Can you hear me all right?
Hey Joe, yes, you're coming through loud and clear.
Let me just try to fix my audio. Something's wonky on this side. Hi, James. Can you hear any better now or worse?
It's about the same, Joe. It's
All right,
not terrible.
I don't know why, but your voice is extremely low for me, and I'm trying to fix it.
Carrie, do I sound okay?
Well, yeah, it's just I'm sure it's a software thing on my side. That's better now. Okay, cool. All right, so you guys are on break right now, and then you're gonna do a panel session and then a talk, right?
We're about to start the evening plenaries. Angela Sui will be the moderator of the first hour, and then you're after that.
Cool. I had planned to speak for like between 20 and 30 minutes.
That's fine.
Works for you. I know it's getting late in the day for people who are actually gathering.
Yes, it has been a long day for a lot of us, so.
What fraction are you physically somewhere, or is it mostly on Zoom?
No, this is all a virtual event. Yeah.
Hello, James.
Hello, Angela.
Sorry, because I'm on the way to Jiuquan, so I'm not very clear can hear you guys. But we have Wenjun. Wenjun today will play the MC role, right? So is everybody in the panel?
So far we have
Jingnan, I saw him. Mr. Zhang.
I think I need to promote some more people. So who
Yeah,
else are we missing?
Check him.
And James, you sound fine.
Thank you, Carrie.
Everyone sounds, their sound is good on my end.
Hi, everyone. I'm Jingnan.
Good evening, Jingnan.
Good morning.
Hello, guys. Can you hear me?
Yes, you're coming through loud and clear, Wenjun.
Okay.
Are we missing anyone else that needs to be promoted from attendees? I see Eric Bao. Should I promote Eric Bao?
Yes.
Okay. Thank you.
So Wenjun, are you in?
Yes, I'm in.
Okay. So for today's panel, Wenjun play the role of the MC. He will cue every speaker to share about their theme. I noticed that there are also 2 or 3 guests still not in our Zoom meeting room. So Wenjun, please double check and just get them in. Thank you.
Okay.
And I have the video ready to go that was forwarded. Do you need me to do anything else besides play the video?
Wenjun, do you need any help from James?
Yes. Can I have the video on?
I have the video ready. Is there anything else that you need me to do?
Nothing right now.
Okay. Thank you.
James, does man need to be promoted to a panelist?
I'm sorry, Carrie, who was that?
Man,
Yes, I believe so.
I see him there. He's, I just promoted him. I don't see him yet. James, you might have to try. I tried a couple times to promote him to panelist, but he's not
Okay.
going anywhere.
Is it the person Manned My?
It is, I think.
Yes,
Uh-huh.
yes.
Yep.
Okay.
And for some reason, it's not allowing me to.
So I cannot turn on my video.
Oh, let me fix that. I'm sorry. I can fix that. Go ahead, try that now. There you go. I can see you, Wenjun.
Okay. Okay, good.
Yeah, man is gone now. I don't see. I see Angela and her kitty.
She's got a big kitty with her this time. I don't see man in the attendees or the panelists.
So Mr. John will be the first.
Why don't we, are you guys ready? We can get started. I can introduce you.
James, man
Yeah.
is James, I'm sorry, man is back as as an attendee.
Okay, let me try again.
Okay.
Hello, everyone.
Okay, it looks like Mand is joining now as a
Yeah,
panelist.
I'm gonna go ahead and mute then, James.
Okay.
Okay, good evening, everyone.
Good evening.
So tonight is the panel on, there's a couple talks we have related to the Chinese space program. So the first panel is going to be moderated by Angela Shui, who is our director of Mars Society China. We're very proud to have her part of our family, and she'll be joined by several folks to talk about the flourished space enthusiasm in China among the ordinary people. Go ahead, Angela.
Angela, it's on you.
Okay. Yeah. Hi, everyone. This is Andrea. As I'm now on the way to Jiuquan. So today I will put. You can see our starman. Wenjun, can you raise your hand?
Hi.
Raise your hand, Wenjun. Yeah, our starman Wenjun today will be our panel MC, and he will cue our speakers. So wish everyone a pleasant night, and very happy to see the Mars Society friends again. So Wenjun, comes to you.
Okay. Hi everyone. I'm so happy here. And today I'll host this panel. And first we will invite Mr. Zhang, the analyst of Aerospace China. Mr. Zhang, please raise your hand here.
Hi, hello everyone.
So let's go start now.
Okay. Hi, I'm Zhang Jingnan from Beijing in China. I'm glad to give my speech. My speech title is The Rising Popularization and Dissemination of Martian Science in China. On July 23rd, 2020, China launched its first self-developed Mars mission. The Long March 5 rocket launched the Tianwen-1 probe, which flew to Mars and arrives on Mars in February of this year. This is China's first interplanetary mission. The lander passed through the Martian atmosphere and landed on the Martian surface. Zhurong rover reached to the ground from the lander and began to explore. Right now, there is the sun between the Mars and the Earth, so the communication will be interrupted for some time before we can communicate again. The Long March 5 rocket is especially used by China for large-scale deep space missions. The core stage uses liquid hydrogen and liquid oxygen as fuel, and its booster uses liquid oxygen kerosene. Until now, it has completed 1 Mars mission and 5 lunar missions. By contrast, the Long March 5B rocket has a larger fairing, which is especially used to larger modules, which is the Chinese space station. The Long March 5 rocket is a core for China's large-scale delivery in space. Due to the experience of lunar mission, the Mars mission carried out 3 submissions of orbiting, landing, and patrolling, which largely inherited the system capability of the lunar mission. In the future, China will use the Long March 5 rocket to carry out more interplanetary exploration, and the mission will be named Tianwen-2, Tianwen-3 in order, including the revisit of Mars and the exploration of Jupiter. While China's Mars mission is going well, the US and the UAE have also carried out Mars missions smoothly. The 3 countries are launching missions to Mars at nearly the same period, which has brought great inspiration to young people around the whole world, as well as people who are not engaged in space work. The Mars mission is different from the lunar mission. The Mars mission cycle is very long. So from last year to the present, and then to the next year, there will be many submissions in Mars mission to continue. This makes people pay attention for a long time. By contrast, the lunar missions are relatively short. For example, China completed the Chang'e 5 lunar sampling mission in December last year, which took only 23 days from launch to the return of the lunar samples to Earth. In China, a large number of Martian science popularization activities have been carried out, and people can learn more about Mars mission, science, and science fiction in various ways. Government official media, such as Chinese Space Administration and the various scientific research departments, are releasing relevant information at every important mission node. for people all over the country and to the world to understand various domestic institutions have organized visits to Mars launch and Mars science bases. The participants are mainly young people. They are in a stage of learning knowledge and very interested in Mars-related content. The combination of going Mars mission and the participating activities can make everyone realize what a great and wonderful achievement it is for human beings to explore planets beyond Earth. Among them, under the leadership of Mars Society, group after group students visited China's space launch many times and learned that the exploration of Mars is based on a country's solid space industry. Only with powerful rockets, reliable detectors, accurate telemetry, tracking and control networks, and smart rovers can human beings go to Mars. The largest number of participants visit the Mars mission at Wenchang Space Launch Center in Hainan Province in China, which is China's only coastal land launch site. In July 2020, the Long March 5 launched the Tianwen-1 probe. A large number of student groups and other civilians gathered here, some in the launch site, some on the beach, some on the deck of ships at sea, and some in nearby buildings. Everyone was watching China's largest rocket to take off and send the probe to Mars. It was about 12 o'clock at noon, and the weather was sunny. Tens of thousands of people at the scene experienced the shock of the rocket taking off with great curiosity and shared their feelings and live pictures online through social platforms. There is no better way to arouse people's curiosity and yearning for Mars exploration. They are not only concerned about China's Mars mission launch, but also actively learned about the US Mars mission and the UAE Mars mission launch in the same period. In addition to this relatively direct spread of Mars science, films about Mars are being made in China and will be released in the future. The US have made excellent films, such as The Mars and the Mars Mission. These films set a good example in the combination of science and film. China is also making such films and computer games. I also put forward some professional suggestions to the producers. Mars-themed venues are open to the public in many cities. For example, the Mars Society has a base for Mars science popularization in Beijing. I'm looking forward to it, and many students are also looking forward to visiting it. The Mars Society has become an important window for more people to learn about Mars. As a major direction of science, space science, Mars science is the direction of joint effort of the global space industry and the scientific research community. This requires joint design, such as designing buildings for human habitation on Mars, co-building, such as how to use 3D printing technology to build buildings on Mars, and common use. After all, it is very expensive and it's a huge waste. For is better, sharing is better. Yes. All mankind needs to work together to Mars to build a place for human beings to live in, which is shared by all countries. so that is feasible. Generally speaking, in terms of Mars exploration and deep space exploration, human beings need cooperation and mutual trust if they want to reach further places. China's Mars science and space science is being read, and I will continue to work hard on it. That's all for my speech. Thank you, Wenjun.
Okay, thank you, Mr. Zhang. That's great. And next, Eric. Eric, can you hear me?
Hello.
Okay, Eric is our Mars Society China family member. And so let's start.
I want to share my desktop. Could you see it?
So we can see it.
Can everyone see my desktop?
Yes, I can see it.
Okay. Hi. Good morning, everyone. Hi, good morning, everyone. Very glad to attend this panel discussion. I'm Eric Bao from Shenzhen, China. My topic is starts Mars life with artificial intelligence robots. Both my son and I are fond of universe probing and artificial intelligence. My son's name is Johan Bao. He's a co-writer of this presentation. He likes sports and painting very much. He drew all the pictures in this presentation. It's a pity that he could not attend this meeting because he had to go to school today. So he made a small video last night to introduce himself. I will play this video and then start my presentation.
Yes, I'm gonna queue up the video. I'm gonna stop your screen share.
Sorry.
It's okay.
I'm Johan Bao. I am 10 years old and
Oh,
study.
no, that's my video, James.
Oh,
Of
okay.
Shenzhen Foreign Language Primary School.
Eric,
I like
you want to go
sports
ahead and
and
share your video
event
again?
innovation very much. I stayed 5 years in South Africa and played soccer there. I like to explore the
I cannot
universe.
see
I
what your
stayed
video
on
is. I'm sorry. My
Earth
mistake.
now, but I hope I could kick the soccer with my friends on Mars one day.
Okay.
Eric, you want to go ahead and share your screen again and play the video? We were not able to see that. My mistake.
Eric, you want to play the video?
Yep, I want to continue.
Okay.
Oh, that's my son's video, and then I will continue my topic. To start life in Mars, it's clear that we need infrastructure, plants, and animals in Mars. So in this presentation, I want to describe who will be the creator of those stuff in the Mars. Human beings could not do this job ourselves. So we, our family life as Verse team predicts, it could only be done by the artificial intelligence robots. So what's the key characters for those AI robots? And it's described as below. Basically, the power resource of AI robots is coming from nuclear energy. To survive in Mars, AI robots could prevent radiation, sandstorm, and freezing weather by itself. AI robots should have the similar skin of human beings to aware of the environment. Furthermore, AI robots have the capability of self-healing and intermittence between each other in case it's broken and off work sometime. So due to the nuclear energy, self-healing, and intermaintenance system, no human being is needed to be involved in Mars. To support the complex construction in Mars, AI robots need 3 key functions. First function, mobile base station to support the telecommunication. Second, AI robots need a function to produce food and oxygen. Third, AI robots need a function to satisfy the human's emotional need in Mars. I will give some introduction of these 3 key functions. Firstly, AI robots will play a role to connect all the human beings and machines in Mars with 10 Gbps up to 1 millisecond latency. Due to the nuclear energy, AI robots could fly anytime, anywhere. Usually, AI robots are doing goods delivery and normal work. However, if needed, they could fly to running different paths to assure the performance of sky network in Mars. Secondly, AI robots could feed plants and animals to make the Mars be an Earth-similar planet. For instance, with special enzyme, AI robots could do the cell-free chemozymatic stuff synthesis from carbon dioxide. AI robots could also bundle with certain plants with water and chlorophyll to generate oxygen in Mars. Thirdly, AI robots will help lonely people to solve the emotional issue because the people in Mars are traveling from the Earth apart from the big family. AI robots have to be programmed with from self-healing to self-learning, and from self-learning to self-conscious. As a result, AI robots will not be only an emotional consultant machine. It could be a self-sustaining body. We have to consider to give them proper rights to live together with human beings in future, including the rights to be friends with human beings, including the rights of the marriage even in future with human beings. There are lots of other issues for us to solve if we want to move to Mars. However, with AI robots' help, Johan and I, the FS Verse team, believe that it could come true one day to build a society in Mars with all the people's efforts. Thanks a lot for your time. That's all my presentation. Thank you very much.
Okay, thank you, Eric. That's lovely.
Thank you.
So next, Mai, can you hear me?
Yeah. Hello, everyone.
Okay, let's start.
Hello, everyone. My name is Mandamai. I'm very glad to have this opportunity to speak. I prepared a video in advance with English subtitles. Thank you. So sorry.
We don't have any sound. When you share your screen, you should check the sound checkbox. So you should stop and start over.
Video is no sound.
No sound.
James, can you play the video?
Is this the same video you sent me one June?
Uh, can you see the video of Mandumai?
I have the video you sent me one June. Should I play that now?
Which video? No, that's mine. That's mine.
Okay, that's the only one I have.
Okay. That's not good. So
Maybe he can email us the video he's trying to play and then we can come back to him.
so Mandumai, your video is no sound. Yeah, your video is no sound. So can you just start your PPT or?
Oh, I see. Sorry.
So you can continue to play the video.
文俊，你可以先让他讲。
文俊，你先来吧。文俊，你先来。
啊，你可以先讲，你可以先讲。
不，你先来吧。
If he's having trouble, maybe we can skip him and come back to him later.
Okay. So next is me.
And June, are you gonna speak now?
Yes.
Do you want me to play your video?
Yes. Okay. Hello, everyone. I'm the Mars Starship Captain Wenjun, and that's my video of my homemade Starship. And next, I want to share my design of my Starship chain. Can you see the picture?
Yes, we can see it.
Yes, this is my design of Starship chain. And you can see the fins on head and on head, and also on the leg. And you can see the detail of the heat shield on the leg.
I
And
think we're
also
looking
here-
at the wrong photo
Yeah.
because we see a girl, an anime girl right now. If you're showing us the model rocket, I don't think we're seeing the right screen on your computer.
And also I designed a badge of Mars Starship mission. And this is my badge of Starship Mars mission. And if you like it, my design, please follow my Twitter or YouTube channel. The ID is Mars Starship Captain. Thank you very much. So, Manduma is okay.
I try again.
Can you play your video?
Uh，我可以再试试。
刚刚是把手机静音了吗？
没有，是共享屏幕吧？是共享屏幕就可以，对吧？
嗯。
哦，那我再试试。
I stopped your sharing, Wenjun. Man, you're all set.
So next is Manduma. Continue to share this video.
No sound. We can't hear any sound on the video. Is there an option when you share your screen on Zoom to include sound? That's usually what we do on ours.
So when use mobile phone to share the screen, there's no sound.
One of our attendees says that if you press the arrow next to the microphone button, you can bring up more options. Yeah, we do not hear any sound.
文具你可以让他介绍啊。
那你可以就是一边放一边讲吧，你直接就说吧。
那个能看到字幕是吧？能看到我是吧？
画面太小，画面和字幕都很小。
我是手机放的。
我电脑连不上，稍等。这样画面大了吗？
哦，这样大点，这样大点。
还是没有声音是吧？
声音的话，你可以就直接手机公放嘛，公放出来声音。
我播放出来了，现在能听到吗？现在能听到吗？
或者你就用英文来介绍也行，大概用英文介绍一下。
对，你就英语介绍一下。
英文要可以的话，我就直接英文说。但是有字幕吧，他们也都能看到。
If you guys want to send me the video through email, I can play it from my end.
慢慢你可以发个 email 给他。这几兆这个视频？
你说现在是吗？
对。你这个视频几兆啊？
嗯？
你这个视频几兆啊？
我没听清楚什么。
这个很大，肯定是。
600 MB。
600，那还可以啊。你发给他那个邮件吧，我发群里面了。
现在是吗？
对。
哦，那我要现在关掉吗？
没事，让他放完嘛。
好，文俊你继续吧，我发邮件。
你可以简单自我介绍一下，然后说一下你的这个项目。
我发了邮件再说吧。Thank you.
Thank you. So we have William next.
So you need William to be promoted to panelist. I'm doing that right now.
Yes.
Hey, William, can you hear us?
Yes, I can hear you. Can you hear me?
Okay.
Yes.
Hi, William.
And should I turn on my video or not?
Yes, please.
Okay. Right, I'm here, and what should I do is share my documents. Yeah, share my screen is better.
Okay.
Mm. So you can see my screen now, right?
Yes.
Okay, nice. Yeah.
Okay, great.
I'm
Let's
sorry,
start.
guys. I kind of messed up the timetable because I was informed to be here around 10 o'clock. Actually, I have another meeting at 10:30, so it's gonna be a little bit conflict. Sorry for the rush. So let me start my presentation. How long time I have? 15 minutes, right?
15 minutes.
Okay, nice. I just want to go through it as soon as possible because the my PPT is still in Chinese. This time is too short, so but I can translate everything by my vocal speaking here. Hello everyone, my name is William Cheng. I'm based in China. This is a Chinese company. I'm the founder of Rocket Pave, which is a rocket company. Our vision is make it reachable. That means to make the outer space reachable and also make the future outer space economy reachable. Maybe I can do like this. Yeah. We built the rocket, but we found the demands. We all started from the demands. Our demands is the space bio. So from this page, we can see a lot of the international biopharmacy, biomedicine companies, the giants like MSD and Eli and GSK. So they all developed their biomedicine through the outer space technologies through the past years. For example, the first one, the MSD, they invent a new biomedicine called Katrina, which is called the international over income is over 15 billion US dollars last year, which is in the year 2020. And this medicine is actually based on the technology from the outer space, same as the others. According to the data from the NASA, for the past 20 years, we can see the total experiment in the ISS, the International Station, Outer Station, Space Station. 60% of the experiments is about bio experiments, and also from the data of McKinsey, the overall the total global income about the outer space medicines is already over 200 billion US dollars, but it's mainly in the United States, which is, I mean, is that means the medicine is developed according through the outer space. For example, the zero gravity and the other stuff. So if you want to do the outer space medicines, the biotechnologies, so we have two prerequisites. The first one is we call that the bio device, the outer space bio device. So from this page, we can see these devices is all developed by ourselves, by our companies. This is the cell culture device, which consists by three components: the micro lens and the cell culture devices. And also this page is also the we call it oh yes, it's microfluid chip, and it's also developed by my company, and also the satellite structure and also the satellite computers. And this is robotic arms. We also using that in the outer space to help the whole experimental process. And also we have our SL, Space Lab Science Lab, based in the city of Suzhou, which is 50 kilometers away from Shanghai. It's not a big one, it's only 500 square meters, but basically we have all the necessary devices and experiment devices for the outer space and also for the on-ground bio biology experiments. Yes. So that's the first prerequisite. The second one is a rocket, but our rocket is a little bit different from the others. We have three specialties. The first one is a fast response. The second one is reusable. The third one is the high launch frequency, which is a fast response. That means, when we put our biosamples into the rocket, we need to launch that in less than 4 hours. So it should be very fast response. So we have to optimize all the process. The second one is reusable. The reusable, recoverable, I'm not talking about the rocket itself. We're talking about the samples, the spaceship, and also the returnable satellites. That's also in our production list.
William, you can flip the page.
Can you see my screen now?
Yes, you can flip the page.
I don't know how to do that, but let me finish my PPT first. Yeah.
William，你可以翻页吗？现在只能看到这前面3页。
Okay, the third specialty is the high launch frequency, the rockets. So we don't need a big rocket, but what we need now is a small rocket, but which is can launch every week. But that's for the future talking. We will do that maybe in another 5 years. Okay, so let's come back to our rockets. So this is a rocket. It's a 2-stage. The first stage is the liquid methane rockets. So the diameter is 2.25 meters, and the liftoff power is 70 tons. The capacity into the LEO is 600 kilograms at the first stage. So at the first time. The first launch will be 17 months later, 2023, March 14th.
William, cannot see your rocket. You can change.
You cannot see my rocket?
Yes. The PPT
I'm sharing my screen. You don't see that?
Yeah, the PPT is not right. Only the first.
Oh, really? Sorry.
Only the first page.
Oh.
Okay. I can see it.
How about now? Is that okay?
Yes. Yeah. Okay.
Yeah. So if there's anything, let me know. Okay, the first rocket, which is going to be launched in the 2023, definitely it's not a good one. It's not a perfect one. We just keep developing to make it perfect. So we have 3 optimized the plans, which is we are planning to launch the third rocket in before the end of the 2024 to make it really commercialized and make its cost performance much better. And let me show you our engine. So this is a video clip from our engine.
You guys have about 9 minutes left in your slot, just FYI.
William, please watch your time.
William, if you're talking, we cannot hear you.
Hi, William. No voice. It's on, James.
He's not on the call anymore. He must have had internet issues. Do you guys have any more presentations, or should we start taking questions?
Oh, okay. We can enter the Q&A part.
I'm sorry, I didn't catch that one, Jim. Do you have any more content to present?
No presentation.
Okay.
Yes, we can enter the Q&A.
Okay. Does anyone have any questions for the panel? If you can go ahead and ask in the Q&A panel. I'm gonna throw it to Altspace, see if they have anything. Altspace VR, can you guys hear me?
Any questions?
Altspace VR, can you guys hear me?
Yes.
Okay. I have a question for you guys. Do you, when you guys are doing events in China around Mars, are people excited about what the potential of the future is for humans to Mars? Like, are you able to talk to folks about that, and what do they say?
Mr. Zhang, can you answer the question?
Yes, the most focused topic in China about Mars exploration is what the environment on the surface. How about people live and work on the Mars? Yes, that's the people who is not working, who is not engaged in space work. So they do not know how people to react if they stand on the Mars surface. So they most people think Mars is like Earth from every side, because example, atmosphere, the gravity, it do not know what will happen if people get on the Mars surface, and how to get to the Mars, how large the rocket will be needed to go from Earth to Mars. Generate the rocket is about 1,000 tons thrust, at least, is needed. So they have no concept about the rocket. Yes, that's this what they are concerned about. Yes.
Thank you.
Thank you.
Anushka, do you have a question to ask?
No, I do not have a question, but Robert has a question that what is the progress of Link Space and other entrepreneurial Chinese launch
This is
companies?
Angela speaking, and I think I can answer Dr. Zubrin's question. Because I'm now in Jiuquan, so I cannot open my video. I just talking in audio. As know, as Dr. Zubrin has been to visit in China and also witness the launch of Link Space rocket test. And as far from I know, because I am familiar with Dragon, yes, so I checked with him. They are ongoing and very good progress. So there are more and more commercial and private space company now in China, no matter rockets and also satellites. Like the Mr. Zhang says, also the fans like us. So there are all a great progress from my view. Yeah. That's all.
Okay, thank you.
Okay, thank you, Angela. Space VR, do you guys have a question? I think they're the last ones, unless there's any other questions. I don't see anything in the Q&A panel. Okay, well, thanks everybody. Thank you so much for participating in our conference. It was very informative. And, you know, we're huge fans of Mars Society China and everything that you guys are doing over there to promote humans to Mars. Thank you very much. Have a great rest of your day.
Thank you, James. Have a good day.
Thank you, James.
Thank you.
Thank you.
Thank you all.
Thank you all.
Okay. Our next speaker is Dr. Joseph Michalski. He's of the Laboratory for Space Research at the University of Hong Kong. Joseph, are you online?
Yeah, I'm just sorting out my situation here. So, oh, I don't know why. Anyway, my video seems to not be working, but that's fine because you don't need it. So I'm gonna.
Let me see if I could fix that. Here, does that work?
You don't need to see me. You need to see slides.
Okay.
Oh, there you go. That's me. How's it going, everyone? Really awesome to be invited to speak with you. Can you see the slides now?
Yes, we can see them.
Awesome. So put that up. My plan is to speak with you for about 20 minutes or so, but maybe a little bit longer. But I just want to tell you in advance that I'm really flattered to be invited to speak with you. I haven't been that engaged with the Mars Society for a little while, but I was a very eager member in the early days, late 90s and so on. And it's about time to get more involved, I guess. So this is a great opportunity, a great launching point for that. And if you want to, yeah,
Joseph, we're seeing the PowerPoint notes view, not the presentation view right now.
Okay, right. Let's see. See if that works.
Sorry about that.
No, that's good. I appreciate.
Yeah, perfect. That looks good.
Awesome. Okay, so this is a great launching point, and we can always stay in touch with each other by Twitter, and you can check out the webpage, clays.space, and so on. Whenever I give a talk, I always want to just mention that sometimes as you go through life, you know, you're a professor or you work with a company and you represent a team, and that's what I do. I represent this team, these folks, and so we work together, and a bunch of graduate students, postdocs, and so on work with me. I couldn't do anything that I do alone, and so I just want to acknowledge that and say thanks. And also, we have some industry partners. Viability is a pretty awesome company operating out of the Bay Area, and we work with them on space-related educational endeavors, and that's their main passion. So I would encourage you to check them out. DMAP, we work with them on remote sensing studies and so on. So we're a lot of, I guess the main point is that we're working together with industry to carry out research and to explore Earth and Mars together. One thing I like to point out sometimes is my background, and it's not necessarily to be so self-indulgent, but I guess what matters to me is that there would be many of you out there who might be in the high school age or university age or even younger, potentially thinking about what is my pathway to become seriously involved in space exploration. I take that to heart because I was that person. I grew up in Cleveland, Ohio, in the rural area, actually, not necessarily in Cleveland itself. And I had no idea that you could actually make a career out of this stuff. And that's why I just want to mention this very briefly so that if it connects with any of you out there who think, what's my pathway in? The answer to you is there are many, many pathways. Okay, there's not just one. You don't have to have a predetermined scholarship to Harvard or Oxford or something. It doesn't have to be that way. You know, I started off at a community college. I went to a state school in Ohio. I grinded my way through and made it to grad school and then on to JPL and worked with the French and UK space agencies and the Natural History Museum in London. Now I'm in Hong Kong. And so there are many pathways to whatever your version of success is. And I want you to feel inspired by that and to think creatively about it, what might work for you. That's all. So lastly, we're talking a little bit about Chinese space program. Now, most of this talk is about Mars science, to be honest, but nonetheless, I just want to be really clear that I'm not speaking on behalf of the CNSA, and I'm not an insider there. I don't work for them. They wouldn't want me to be telling you what they're doing because they honestly don't reveal a lot of their details to anyone. So I'm physically closer to it all here. Hong Kong is part of China and I'm part of China. So I'm close to the action in a sense, but I'm speaking for myself and I just have to be clear about that so that nobody who's working at CNSA, I don't want them to feel offended in any way. Most of you are aware of how we study Mars. How do we gain information? Well, we can use remote sensing, satellite images, telescopes, and so on. We can study meteorites that have landed here that contain chunks of Mars. Of course, those things are lacking context and we don't really know where on Mars they came from. We can study Mars through surface operations, landed missions. We can do analog studies, go to the most remote deserts on Earth or places like Iceland that are quite exotic and unusual, or Antarctica. We can study analogs. We can also use theoretical models to understand Mars. I personally tend to use remote sensing data the most. And that means that we look at reflected sunlight, the infrared portion of the sunlight largely, or emitted radiation, heat radiation. You can take the emitted heat and process it into something called emissivity, which gives you mineralogy information. We also can do active remote sensing. That means bouncing radiation off of the surface. In this case, laser altimetry. All the great topographic maps you see of Mars, those were made using laser altimetry. And so that's what I do. And it's really exciting because this is an amazing time to be a scientist or any member of the community exploring Mars. How cool is it that right now we have more active missions than we've ever had on the surface or in orbit. And we have real legitimate major involvement from the private sector. Now, you know very well, this isn't a new thing. The president of Mars Society, I believe, worked with Lockheed or Martin Marietta early on, and there have always been these huge contracts with private industry. So that's not a new thing. But I guess what's going on now, what's really exciting is that the involvement is legitimate and it's moving the needle. We're seeing pressure, and we want pressure. We want pressure on each other. We want positive kinds of tension and pressure, so that we can push each other, so that we can push government agencies, space agencies to do more. And I think that's the role that China plays as well. I don't want to speak too much about how things actually function within mainland China, because I'll be honest with you, I actually don't speak Mandarin and I don't read Chinese language. And it would be wrong for me to pretend that I understand so much. I don't. But I've worked a lot in mainland, and there are the boundary between what is private industry and what is government is not as obvious as what you have in other models. But But mainly the thing for me is that China itself will make bold decisions. They've sent the first ever combination of orbiter and rover together and successfully done it, pulled it off. It's amazing. And they're both operating flawlessly. So that's super cool. And that creative spirit and competitive energy is good for the world. Zhurong is now on the surface of Mars. Look at, here's a sort of family portrait of Mars rovers. You can see that Zhurong is a solar powered one, about bigger than the Mars exploration rovers, sort of like Curiosity rover size. And remember that solar powered rovers, as opposed to nuclear powered, right? You have two options, solar or nuclear. And solar powered ones depend, of course, on the sun, and they need to be dust free on the solar panels to operate. Now, what happened with the Mars exploration rovers? Those were launched by NASA in 2003, landed early 2004. One operated for about 7 years and one for, I think, what was it, 14 years or something? The Opportunity rover. So the reason those were solar powered, and they were able to do it because they had the solar panels cleared of dust by dust devils, meaning little mini Martian tornadoes that clear off the dust. So it remains to be seen whether Zhurong will have similar luck in that regard. We don't know. It's landed in Utopia Planitia. So when you look at this image, what do you see? It's a pretty unusual landscape, right? These giant fractures. This is not the actual landing spot itself. This is just representative of Utopia. It's a cool image. That's what I'm showing you. This is from the HRSC instrument, German built and run on the Mars Express spacecraft. So these giant polygons are indicative of ice in the subsurface. So the details of exactly how much, where, what depth, all those things are for scientists to debate, but it's pretty clearly formed from ice. One of my students, Ben Long, he has written a paper about the landing site. And although this isn't necessarily a science conference, I just want to point that out. This is something that's out there and recently published. So we're just talking about what's available to the Chinese rover Zhurong in Utopia. What can we explore with that spacecraft? So that's the location. I don't know if you can see my pointer. And here is the place from orbit. And here is an image released by the CNSA showing the landing region. So the cool thing about it is that you have a bunch of different landforms to explore. Among them are these weird cones. The cones are effectively like they look like a cinder cone. I don't know if you've been to Sunset Crater in Arizona near Flagstaff, or maybe you've seen these in other places. They look a bit like volcanic cinder cones, but there are some differences. And when you look at them in detail, they actually seem like they might be potentially mud volcanoes, not actual volcanoes. So I'll come back to that in a moment, but that's a big difference. Now, this is a selfie taken by the rover. It dropped the camera down and backed away and took a photo of itself. How cool is that? I guess, surprised nobody has thought to do that before. The confluence of technological capability and awareness. This is a great move, interesting and breathtaking to see like a selfie view of these robots operating on Mars. The rover has traveled over 1 kilometer already. As has been mentioned already in this conference, Mars is in conjunction right now. So that means you can't communicate with the robots over there very easily. And that's the case with Zhurong. So it's chilling out at the moment. And once we come out of conjunction, we'll get to operations again. But it's important to note that the mission has already been a technical success, has driven over 1 kilometer. And the pace at which this rover travels is faster than what the NASA rovers typically do. Now, I've worked with rover teams, and the balance among the team members, the engineers, and all that, it's really comes down to what are you trying to accomplish, how quickly, how do you have to give up the desire to measure rocks in situ at the expense. If you wish to travel quickly, you have to give up some of the observations you wish to make. That's the point I'm trying to make. So this rover has been cruising along, and it could go faster, could go slower, depending on how much detail you want from the individual spots. But you can see that it's been able to measure light toned dunes and interesting soils, rocks, and so on. It's a cool site. From Bin Long's paper, here he shows all the different types of landforms that are available that the rover might ultimately be able to visit, including these cones, fields of cones, polygons, and patterns of polygons, impact craters, knobs, mesas, and so on. This area should be pretty ice rich, and many of you, if you're still hanging on from earlier this morning, you heard Nate Putzig speak about ice on Mars. So obviously, with this particular crowd, I don't need to explain the importance of ice for us, people who want to go live and work on Mars and build businesses and so on. Ice is critical, and it's a strategic resource. So one of the interesting things that will play out in the coming years will be how do different nations deal with ownership of resources on Mars. I know this is covered by the Outer Space Treaty, and if you haven't read that recently, have a look. But generally speaking, nobody owns resources on another planet, but when they get processed by a nation, they become a different asset, so that'll be something that will be interesting. So that the ice itself is not, nobody owns that. But when it gets processed into a fuel, then somebody can own the fuel. So that'll be an interesting sort of point for discussion in coming decades. But this rover will map ice using ground penetrating radar from the rover itself. So that'll be exciting to see here's an example of what GPR, ground penetrating radar, can do. And so there just haven't been a huge number of data points yet. They haven't been released yet. So we don't know exactly what Zhurong has found, but the same type of technology has been hugely successful for the Chinese on the moon, not for ice, but for measuring the regolith. And the word, the most technical word would be discontinuity. You're looking for differences in reflectors in the subsurface. Those differences among the reflectors can be rock, soil, sand, buried ejecta, can be ice. So that's what they're looking for. In the area where the rover landed, it's kind of in a transitional spot between the polygonal terrain and the ones with lots of cones, pitted cones. So we don't know exactly why that is the case, but it's exciting to land in an area where things are going on. And one of the main points I want to make is that this area, it's ice rich and considered to be what we call permafrost. That means like periglacial, near glacial in the high Arctic or in the Antarctic, similar to that on Earth. And we know that in those areas, as a function of climate change, and I'm not, obviously interested in having any debate about climate change being human driven or not, it doesn't matter to me. Climates do change, and that's a fact. So when they change, things like permafrost melt and sublimate, and you get collapsed ground and release of things from the subsurface. So that happens on Earth. This is an area in Siberia with huge amounts of collapse and melting of periglacial material or permafrost. We think similar things have occurred on Mars. Now on Earth, those things, they can release methane from the subsurface. Now, I'm not sure how aware everybody is in the audience, but there's a lot of discussion about CO2 as a greenhouse gas, and it is a greenhouse gas. But you know what's really a greenhouse gas? It's methane. So on a side note, personally, when I see on the news one day, it says methane has gone up for the 20th day in a row, that's when I start getting really concerned. That's a huge deal. And so it's a much stronger absorber and so on. So we think that was an important part for greenhouse warming on ancient Mars. We detect methane on Mars today, occasionally in wispy transient measurements, but we don't know where it comes from. And it could come from melting of permafrost on the planet. It's one possibility. This is a complex diagram on the right side from the paper I told you about. I guess if you just look at this diagram, you see that the ground surface is here, and you have permafrost and frozen ground, and you have methane sources in the subsurface, and that stuff will get released to the surface due to melting of the permafrost or other types of activities. Now, does methane mean microbes? No, it could mean that. Measuring it doesn't mean there are microbes, but it's an energy source for microbes, and it could be a product of metabolism of microbes, and we can't rule those things out. So in fact, a colleague of mine, Jesse Tarnas, we wrote a paper led by Jesse in astrobiology recently about the viability of a modern biosphere in the subsurface of Mars. Pretty cool stuff. You know, we know that the surface of Mars is bathed in radiation. It's super cold. It's hyper arid. It's ultra oxidizing. It's not a pleasant place. If you were a microbe, you wouldn't want to hang out on the surface of Mars. But the subsurface, yeah, maybe could. What do we know about the deep biosphere of Earth? Well, a lot. We're learning a lot. We've learned a fair bit in the last 20 years, but prior to about 20 or 30 years ago, we didn't know hardly anything about it. There's more life. If you were to put it on a scale, there's more biomass in the subsurface of Earth than the surface. Even with all the rainforests, even with all the people, all the whales, all the bugs, everything, more biomass in the subsurface. Amazing, right? So while there's an emphasis on surface processes for Mars, people are obsessed with channels, rivers, lakes, for good reason. They're cool. And NASA will keep going for these environments. Perseverance has done that, and this is a great site, Jezero crater. It'll be interesting to explore. But the subsurface may be really where it's at. Mars, because of its lower gravity, it has more pore space. Just think about it. All the gravity pushing down on the ground compacts the Earth. With less gravity, there's less compaction, so there's more pore space. More pore space means the space between all the silicate grains where bugs can hang out, where water can be, where nutrients can be. And if you were to model this, which we've done, you'll find that there all the goodies you need for life are there on Mars. We don't know that life is there, but in the subsurface, everything is there. So Mars is really important because it actually could contain the holy grail of how did geobiology become biology? How did you make the first cells? On Earth, if you look at the origin of life on Earth, going back from modern time to 2 billion years ago, 3 billion years ago, 4, the Earth's crust is not very well preserved. So it's hard for us to answer. How did life form? We don't know. We have some ideas about different hydrothermal environments and so on. We have some concept of when different things evolved, like when did the first cellular life occur, cells with nucleus, when did photosynthesis occur, all that stuff. But the crust, the actual geologic record is not well preserved. And on Mars, it's much better preserved. So that's the key point. This is the most important thing about Mars. It's got a geologic record of this earliest important events. And if they didn't occur, if biology never occurred on Mars, fine, okay. Biology will occur on Mars when we go there. But whether microbes ever formed, we don't know, but we must go look. And I would argue that the key point is that not necessarily to find microbial life, although that's awesome, and we hope that would occur. This diagram shows that even if you, I'm not sure if you can see my pointer or not, but you search for life on Mars, and let's say you're lucky enough to discover it, then you would quickly just answer, well, how did Martian life form? The same you would ask on Earth. Well, what was the previous step? And then you get to searching for clues to abiogenesis. So I would argue, like, just skip these other ones and go straight to searching for clues to abiogenesis, the prebiotic chemistry and all that stuff that leads to life. So while NASA is always pursuing lakes on Mars and things like that, that's great. I mean, huge amount of respect for how NASA does things. There's another way to do stuff, and it could be that searching in the subsurface, not by drilling or anything, but to look where materials may be exhumed from the subsurface, that could be the way to go. And that could be one way for China to have an advantage, you know, in this, in terms of catching up in Mars exploration, to go to the most exciting places, or to extract materials from fundamentally different types of deposits. Now, China's plans, that they don't publish everything they plan to do, but what they've roughly said is that they expect to do a sample return mission in the late 2020s. It sounds horribly audacious to say, well, we'll just go do a sample return mission, but guess what? They've done it, man. They've already done it. It sounds audacious to say we're going to send a rover and an orbiter together in the same mission in our first try. We're going to pull it off. Well, guess what? They did it. So they said they're going to do this. They're going to go get a sample and just bring it back. While everyone else, while NASA and ESA spent 20 years screwing around with the next rover and talking about sample return. NASA spent 50 years talking about sample return. Well, guess what? China's just going to go do it. So that's awesome to me. That's exciting. And to pretend that we know the exact details of how are, you know, it's misguided. But what I would say is that they've done it with Chang'e 5, and brought the samples back from the moon. They know how to do it. And guess what? They've allowed scientists to apply for those samples, for those materials to be distributed for exploration. That's great. That's the way we want science done. So I'll leave you here. I'll leave you with this, and we can have some discussion if you wish. But that's my excitement for the future, is that China is really pushing the envelope, and NASA's great, European Space Agency, great, India, great, Japan. We have so many players now. Great. More, better. That's what we want. Thanks.
Thank you, Joe. Anushka, do we have any questions for Joe?
Yes. So one of the questions was like, how can we erupt the moon on Olympus to increase its magnetosphere?
Oh, it's not the moon, Anushka. It's Olympus Mons, the volcano. Yeah.
Yes, sorry.
How can we erupt Olympus Mons for enlarging Mars's magnetosphere?
Well, okay, so to be clear, the mystery of Mars' magnetic field is one of the most interesting parts of Mars science. Now, what do we know about it? We know that it had a very strong magnetic field early on, and then we know that it's not there now. Those two things we know for sure. And you can measure roughly when it may have stopped, when the magnetic field may have stopped, by looking at something called remnant magnetism. That means the magnetic field gets stored within magnetic minerals in the rocks. And then the rocks form and they sit there for billions of years. So some rocks will have it, some rocks won't have it. And the boundary between the rocks that have it and the ones that don't have it is when the magnetic field shut off. So that was about 4.1 billion years ago for Mars, as far as we know. I guarantee you there'll be big discoveries in this area in the coming decade, but that's the number that we use. And there's no way to turn it back on. And that's going to be the problem for humans who want to go create a society on Mars, because the magnetic field on Earth protects us from solar energetic particles and some forms of cosmic radiation. So not having it on Mars is problematic, and there's no way to turn it back on. That'll be something we just have to deal with.
Okay, any other questions? Looks like
There's
one in the
another
Q&A.
question. Yes. That is like, what drew you to do research at Hong Kong University? So is that research environmental? Is the research environment or CNSA's ambitious goals?
Well, if I didn't understand the question, you can correct me. I'll give a short answer and then you can tell me if I did not understand. At University of Hong Kong, I'm a geologist, and so I study the Earth and Mars. Most of my research is on Mars. We're interested in many different aspects of exploring Mars, mostly to do with understanding how the planet came to be geologically. But we also do some applied research. I have a postdoctoral candidate who's doing 3D printing with clay minerals. So clay minerals, the things that you make pottery from and so on Earth, the clays exist on Mars. Now they're important for lots of reasons. They're important for understanding climate and preservation of ancient life potentially. But the clays themselves are a resource. You know, they contain water that can be extracted, and they are also it can be used for 3D printing. So one of the things we're doing is trying to figure out how to do that for Mars.
Okay, thank you. I had a personal question. So have we found any similarities between Mars soil and Earth soil?
Yeah, there are a lot of similarities. One of the effectively what you find on Mars is basalt, which is like the kind of rock you have in Hawaii or in Iceland. And so it's a dark volcanic rock, and the soil that forms from it is ground up volcanic stuff. The word soil, by the way, on Earth is problematic because soil on Earth is always mediated by microbes, always. So that's why you hear scientists sometimes say regolith, because regolith is a more boring but more accurate term. There's regolith on the moon, there's regolith on Mars. We can't, for somebody who studies soil, they would be maybe offended if we said there's soil on the moon, because there are no microbes to facilitate some of the chemical processes and so on. But other than the microbe part, the comminution of the volcanic material into volcanic particulates is very similar to what we see on Earth. In fact, I have a mate named J.R. Skok who runs a company called Made of Mars, and we looked at ways that you can take volcanic material and process it into products for that humans might want. So check out Made of Mars.
Okay, great.
Hi.
Go ahead, Jay. Altspace VR, go ahead.
Can you comment on the work of Dr. Gil Levin?
Can you explain it again?
Oh, Dr. Gil Levin, the one who made one of the life science experiments on the Viking lander?
The labeled
And
release experiment
astro-
on the Viking lander that had signals, the positive signals for life. It's a little bit of a controversial experiment. Can you tell us anything about your thoughts on that?
I will do that as long as you put your mohawk back on the screen, because I was very taken with that. Yeah, that, I mean, my best understanding of that suite of experiment, yes, is that the Martian surface has an unusual suite of oxidants that weren't predicted ahead of the Viking experiments. Now, because as Carl Sagan had said, like, what exactly what did he say? Is that major conclusions must be met with substantial evidence. The evidence is consistent with metabolism, but it's also consistent with there just being hyper oxidizing material. So that's the bottom line, is that it's inconclusive in those regards. We didn't know there were all these perchlorate and weird chemical compounds on the Martian surface that are so oxidizing. And so that experiment wouldn't be designed the same way today, and it's not conclusive as a result. That's the end of the answer.
Thank you, Joe.
Okay, thank you. So the question was, like, he wanted to know what is the research culture in HKU, like how is it compared to US or Europe, and what?
That's not, what is the research culture like?
I think he's asking, do you find that the research culture in Hong Kong and China in general, is it more ambitious compared to, say, the US or Europe? And is that why you work at Hong Kong U?
Oh, well, no, I don't think it's better or anything like that. I just work here because I just chose to do something exciting. But there are advantages and disadvantages. Advantages would be that there's a huge trajectory toward space exploration in China, obviously. And Hong Kong itself, to answer your question, I'm sorry, I don't want this to be boring, but Hong Kong itself doesn't see itself as the city, and the city itself doesn't see itself as a spacefaring, technology-driven part of the world, but that is changing. So, and I came here to help be part of that change. Now, I guess the truest answer is that we'll see. You know, it's a period of immense change in Hong Kong in a lot of ways. And some of those things are exciting and some are less exciting, but research will be one of the areas that I think will maintain and become stronger, because China is very invested in science. So what I think what happens in the States, for example, I am American, so sometimes I speak freely about American culture. Forgive me for that. The anti intellectual behavior that occurs in the States is astounding to me, and we don't see that here.
Okay, well, on that note, I think we're going to go ahead and end the evening. Thank you so much, Joe, for participating in our conference. We really appreciated your remarks, and thank you so much.
So thanks, everybody. Thanks, James. Bye, humans.
Okay, everyone. Well, it's been a long day. Let's all get some rest, and we'll be back at it first thing tomorrow, 9 a.m. Pacific, for the morning plenaries. Thanks a lot, everyone. Have a good night.
Bye. Enjoy Chrissy Planet Show, wherever you are.